Hello and welcome to Making Tech Better, a fortnightly podcast on how to improve software delivery. I'm Carl Chapman, I go by he, him, and I work as a senior engineer at Tech, who are kindly sponsoring us. This week's guest is Sam Newman. Sam literally wrote the book on microservices, we'll come back to that in a bit, and currently works as an independent technology consultant. Hello, Sam.
Hello, how are you?
I'm good. Where I want to start us is kind of with our main topic, because you've written the book on this, you've run courses on this, so I want to talk about microservices. And my first question is, what is a microservice? Like, what's a good definition of that?
It's a design technique that maximizes the amount of buzzword hyped technologies that you can cram into one project at any given point in time. That's the kind of, the slightly cynical version. I describe microservices as being a type of service-oriented architecture which focuses on achieving independent deployability. The boundaries of microservices are typically designed and sort of structured around a business domain. And I describe them as being a subset of service-oriented architectures, as there are lots of service-oriented architectures where the individual services do not have independent deployability. So I'm trying to be very precise about that differentiation between that and other types of distributed systems that you might see.
Okay, so it's like a subset of distributed systems, do you?
Well, I think you could argue that you've got distributed systems as the overarching concept, then you've got service-oriented architectures, and then you've got microservices. So it's a subset of a subset in many ways. And, again, definition of a distributed system is, you can talk about it technically, which is any system where you've got two computers communicating over a non-local network. If all of your programs are communicating on the same machine over a local network, it's not a distributed system. But the moment you go over a network, you're sort of building a distributed system, whether you realize it or not.
I think that happens accidentally quite a lot. People start building architectures that have those qualities without necessarily thinking about the trade-offs that they're making.
I think something else happens as well, which is people assume that what they're doing now isn't distributed. And then that what they're going to move to is distributed, and there's somehow a magical switch. That's not really the case. I think most of us are already building some form of distributed system. It's just a much, much simpler one. This is why I kind of talk about this shift from, say, more of a monolithic single process-based deployment topology to a microservice architecture. It's more like degrees of complexity. As you become more distributed, on the one hand, you get more complexity, more pain, more suffering. On the other hand, you hopefully create more options in terms of how you're going to solve certain problems. So you give yourself a lot more flexibility. That's kind of the trade-off you're inherently playing here.
So there's a theme I see coming out here where it's more subtle than a choice between monolith and microservices.
Yeah, it's probably worth also talking about at least how I define a monolith in that context as well.
Yeah, please.
I describe a monolith as a deployment choice or a deployment constraint. So if you deploy your entire system as a single unit, that is a monolith. And of course, you can have the classical view of a monolithic deployment, which is, say, a Ruby on Rails application, for example, which is, almost like the canonical example of a framework designed to build a simple web-based monolithic application. All my code runs in a single process. I deploy it as a single unit. You then go to the other extreme, which is I've got a service-oriented architecture. I've got 20, 50, 100 services, but whenever we do a release, I have to release all of those services together. That's a distributed monolithic application.
Okay, so it doesn't just refer to sort of, is my code in one repo or many repos? There's more to it than that.
Oh yeah, and that's a whole other conversation because that gets there's some religious wars about that whole thing, right? So, how you organize your code can be orthogonal to how you do your deployments.
Yeah, I see all this conflated quite a lot, I think.
Yeah.
People tend to think of it as, we're either over here or we're over here. There's only two options when it comes to microservices.
Yeah, and for me, that's why I talk about, you start with that dial down to zero, where you don't have any independent deployability and your system is maybe mostly not distributed. And as you turn that dial up a little bit, you add one or two microservices, you're increasing the distribution of your system. So you're adding a bit of complexity there, but you're able to dip your toe in the water of microservices. And then as you get more confident with that process, you can turn that dial more aggressively to the right. So you find the right spot for you, for your organization.
I'm struck by how similar this is to normal development, right?
Yeah.
To work in small iterations and to get a fast feedback loop going. Is it just no different in this area? You think the same patterns still apply?
I can't speak for other people who are interested in the space of microservices, but the reason I am is because of continuous delivery. So people have written the code, we need to get it into production. So what are all the things that we need to do to make sure that we can get that software into production as quickly and safely as possible? Then you're moving into, okay, now can we automatically deploy our software? Do we have test automation? Maybe we're looking at more aggressive infrastructure automation to remove the manual processes in shipping our software. That's what I spent like a good chunk of my career as a consultant doing at ThoughtWorks. And I realized that often you do all of those things, and quite often the architecture of the software itself was one of the big inhibiting factors.
Yeah, okay.
Now, I still consider a lot of those things I just said to be the low-hanging fruit. You should do those things first. But once you've done those, you often realize we've got a system architecture which actually inhibits our desire to release more frequently. And fundamentally, the easiest way to release more frequently is often to reduce the scope of each release. So if I can make the scope of my releases small, I'm less likely to make a mistake. If I do make a mistake, it's easier for me to work out what the problem is. So I was thinking, okay, what can we do architecturally to allow us to reduce the scope of a release? And this really comes onto that idea of independent deployability. You might have a system of 10, 15, 20, 100 microservices. But if I've got a one-line code change that I want to make to one microservice, I should be able to make that change that service and release and deploy that service without having to change any other part of my system.
Yeah, so I want to dig into that a bit, because this idea of independent deployability, I think, is quite interesting to me. And something I've seen you talk about before is these concepts of cohesion and coupling. And obviously they're concepts already in system level architecture.
Yeah.
But I'm interested in how they relate to microservices and distributed architecture.
If we want independent deployability, we don't want coupling. So there are different types of coupling and different definitions of coupling. But the coupling I'm talking about here is that problem that you encounter where you end up wanting to make a small change that somehow ripples across the system. You've got units of code, broadly speaking, which are coupled together. I change one thing and I have to change lots of things. And coupling and cohesion being quite strongly linked. When you have code which is highly coupled, cohesion tends to be low.
What does cohesion mean in this context?
I struggle with the definition of cohesion more than anything else. The definition I heard from someone, I can't remember who the definition was from, was the code that changes together stays together.
Okay.
So to give you a very simplistic example, if I wanted to change how I manage the life cycle of an invoice, I would like to not have to do that in 15 different parts of my system.
Yes.
Because it's more work. There's more stuff that has to go wrong. There's more things that might need to be done in conjunction with one another.
I think I see cohesion as things belonging together for a good reason. Like if coupling is things belonging together for a bad reason, then cohesion is kind of the good side of that.
I like that definition as well. But the important thing about that linkage, though, is it does mean you can tackle this from either point of view. Sometimes the way you can decrease coupling is by improving the cohesion. Sometimes, though, you might have code that's collected together not for any good reason, and you need to sort of push that code away to give you the ability to change those things more independently. You want to avoid the big ball of mud problem. That was my focus, actually, during the sort of first edition when I wrote the Building Microservices, I suppose, back in 2014, came out 2015. The thing that's crystallized my thinking even more than that, though, is this concept now of information hiding, which is heavily linked to those ideas.
Okay. Can you talk to me about information hiding? What's that?
So basically, it's sort of a foundational principle of modular architecture. So if we think about coupling and cohesion, you could apply those at different levels and they have different meanings at different levels. Information hiding is a concept that was developed to basically help guide us in terms of how we think about modular decomposition of software. Now, I said that microservices are a type of distributed system. They're also a type of modular architecture. So if you think about what a module should do, we take a big program, we break a program down into modules. Those modules should allow us to reason better about the problem space because they're easier to understand. Modules also theoretically give you the ability to do work in parallel because I can have different teams working on different modules. And hopefully, if I do modular architecture right, I get the ability to change one module without having to change the rest of the system. These are basically the three criteria for a good module that David Parnas outlined in his paper on the criteria to be used in decomposing systems into modules.
That's impressive that you can quote that off the top of your head.
It's the only one. So Parnas was looking, okay, we've got this idea of a module. How do we find good modules? And so in that paper, he actually kind of compares two different techniques almost to find module boundaries. In one, he takes almost a workflow-based approach where he has a program and he basically models each step of that program and has a module for each step. And what he found was that process often ends up in lots of changes having to be made that ripple across those module boundaries.
Because there's common things across each step.
Yeah, and it's also like, I think Jim Weber sort of described this to me once as like a sausage factory. 1, 2, 3, 4, 5, everything's in a line. And every now and then you do get problems that just are that sort of thing. But most programs aren't really like that. So what's the information hiding part? Well, the idea is that inside a module boundary, what you're trying to do is hide that code which changes frequently.
Yeah.
So code that changes a lot should be hidden from the outside world. So within a module boundary, the stuff that's hidden can change freely. And if I can change that without changing the interface of the module, then the rest of the program will continue to work and to continue to operate. This already sounds familiar. This is what we think of as encapsulation in object-oriented programming.
Yeah.
So if you think about it, hide stuff in the modules. Okay, great. What's that got to do with microservices? Well, let's talk about independent deployability. If I want to make a change to a microservice, deploy a new version of that microservice into a production environment, I've got to make sure that I haven't broken the consumers of that microservice. Because if I have, I've broken the system. And guess what? I don't then really have safe, independent deployability. So if I want to be able to make a change to a microservice and deploy it into production, I've got to maintain backwards compatibility with the consumers of my microservice. So that basically means is I need a stable interface. Turns out if you get good at hiding the stuff that changes from stuff that doesn't, you end up with stable interfaces. You maintain backwards compatibility, and you'll find that independent deployability is much easier to deliver on as a result.
I've seen a little bit of how to influence this design through testing at the code level, but not a lot about how to do it at the system level. What do you think the role of testing and I guess observability is in microservices? Like, how do you have that design pressure to make sure that you are building things that way?
I think it actually starts with a mindset shift. I think you've got to recognize that 99 times out of 100, a microservice exists to be called by other things, whether it be a user interface, an API gateway, another microservice, whatever it is. So you want to adopt a consumer-centric mindset. So when I'm thinking about information hiding in the context of microservices, my default position is I'm not exposing anything unless someone absolutely needs it.
Yeah.
The reverse mindset I often see is people say, oh, I've got this data in my database. I'm not sure what people might want in the future.
Someone might need it.
Exactly. So I might need it. I'm just going to stick that on an API. Job done.
Yeah. It's simpler. It's easier. And later it isn't.
Yeah. But coming back to encapsulation as an analogy, thinking that you've done anything around hiding of information or hiding of implementation detail, you haven't in that situation. This is the equivalent of in object-oriented systems of having private fields and public getters and setters.
Yeah.
That's not encapsulation.
Yeah.
But I think it starts with actually often a culture or a mindset, which is outside in, consumer first. If you think about your outside in design, I think it's much easier to come up with an interface which only exposes what needs to be exposed. And that also has the added benefit of your interface should be easier to use. I mean, see it like a user interface. It's just the user of your microservices interfaces are fellow developers that work at your company. And I think it's crazy that you're not interested in making your fellow developers' lives easy because they know where you live, right?
They can come over to your desk.
They can come over to your desk. They can Slack you off over Slack. So I think it's a really subtle thing, but just start outside in. Don't expose anything unless you have to. You can always expose things later on. But if you think about what people need up front, have conversations with them if you're able to. I think that places you in a pretty good space to start at least getting that separation from a design point of view.
It's interesting. I think you're reflecting on something cultural here. I think that there's maybe this image of a company that's using microservice architectures, or an organization having like very isolated pods for each microservice. And what you're talking to me here is they need to talk to each other.
Yeah. A pod can only be completely isolated if it never calls anybody, no one calls it.
Yeah.
The secret often of autonomous teams isn't isolated teams. So often what you're trying to do when you're thinking about your organizational design or your system design is not eliminate all cross-team communication coordination. It is to reduce the amount to those areas where it's really required. If I'm working on the payment gateway and I've got a separate team that manages the fraud stuff, we should have a conversation. That's a required coordination. And that coordination between our teams, we would expect to be reflected in our system architecture. We can't eliminate coordination between teams. What we can do, though, is reduce it as much as possible. And if you see a service, for example, that depends on lots of other teams downstream, that can sometimes be a sign of a potential problem.
Yeah.
Because if you think about the team owning that microservice, they're going to have to potentially coordinate with lots of other people downstream. So sometimes your system architecture can actually show you potential organizational challenges that you might have.
Oh, definitely. Yeah. Most people I find have this intuition, but then don't necessarily know where to go with it when they say, oh, we changed this and this broke. It's so strange, right? And that's a sign that those two things are too close together. Whereas, oh, we changed something about payments and something in fraud broke, and people are like, oh, okay, that makes a little bit more sense. Yeah. Those two should have some relation. And I think that's like your intuition speaking about cohesion, about what should be together, or at least close.
Yeah. Like you might not like it to have broken,
yeah,
but at least you can understand why it might have.
Yeah.
I think if you look at the organizations that have hundreds of microservices, they solve these problems without realizing it sometimes. But if you want independent deployability, you need to get good at not breaking other people, however you do it. So part of it could be by having a design ethos like I just shared, thinking outside in, thinking about information hiding, that can help. But it also is beholden upon you to look at what adequate safety guards you want to put in place to try and catch those breakages before they occur or before they're seen by an end customer, an end user of your software. So, this is where testing obviously can be highly useful. I'm a big fan of things like consumer-driven contracts in this space. But this is also another reason why I actually quite like the use of explicit schemas for my service interfaces, because that actually allows me to check for structural backwards compatibility before I even check my code in. And so I think that's an area where not enough work is being done. I think people are having to do an awful lot of checking with automated tests to make sure they haven't broken compatibility, where actually a lot of what they're checking for are just simple structural issues. There's an awful lot of people running around saying, oh, we don't need a schema. And it's like, well, no, you just don't have an explicit schema.
Yeah. Just because you haven't said it out loud, it still exists.
Yeah.
There's always an interface when you're talking to each other. Even if you haven't defined it, there's always an interface.
Exactly. So this is, I think, Martin Fowler was kind enough to review the second edition of Building Microservices, and he picked me up on this because I used to talk about schema-based versus schemaless interactions. He said, no, there's always a schema. It's just whether it's explicit or not.
Yeah.
So if you send, say, a JSON payload over HTTP and you say, I've got no schema, well, the consumer of that payload has a set of expectations about what structure they expect that JSON to be in. The thing is, if you don't have an explicit schema, all of that is just completely implicit. So I think having that explicit schema is just about being more clear to everybody.
It's another example of being consumer-led, right? Like you're being kind to people by telling them, hey, this is what we do. You're being like open and transparent with them in a way that hopefully helps them work better.
And ideally, that explicit schema is going to be one of the concrete outcomes of the conversation you had with your consumers.
Yeah, let's work on it together.
Yeah, exactly.
Let's work out what you need. Let's write it down. And so we can both look at it and go, yeah, I think this is right for a first pass.
Now, it's got limitations, right? Because all a schema can do is talk primarily about structure. So it can say, this endpoint takes 2 integers and it returns a 3rd integer, and that endpoint is called calculate.
Yeah.
I think for when you're thinking about compatibility checking, the schema does the easy bit and then the test can focus on the hard bit. But if you don't have the schema, not only do you lack clarity, but you also are asking your tests to do more work that they shouldn't have to do.
So just a quick shout out to Maytech, our sponsor. Maytech are software delivery experts, mainly working in the public sector. I've been working at Maytech for a few years now, and I've learned more than I did anywhere else in such a short space of time, all the while being supported by a bunch of lovely humans. You can find us on Twitter, that's at Madetech, which is MADETECH, and we're hiring across a number of regional offices across the UK. Go to madetech.com/careers to find out more about that. Oh, we've also got some books. Head to madetech.com/resources, get yourself some free books. All right, let's get back to Sam. I'm interested in what you think about the possible organizational approaches to this. So I've seen organizations where they're starting down this journey and a particular team is sort of an advocate for microservices, starts to build a few out, starts to sell that to other people in the organization. I've also seen organizations where it's very upfront and someone says, we're doing microservices now.
Well, let's talk about the oxymoron of the DevOps team.
Yeah, let's.
Let's ignore that one because, if I see an organization creating a DevOps team, it's like, do you understand what this is? Because I don't think you do. But let's
we can be angry about this for 10 minutes if you like. I'll enjoy that.
Oh, no, I've got other places I'm angry. Okay, so when I see a team think microservices are a good idea, a lot of the time you can have limited impact because you're only going to be able to affect your own local world typically. So if you're adopting microservices just within your team structure, on the one hand, you're keeping that experiment small scoped. It's much easier to assess the impacts. And almost by definition, that team was willing and is going to put the extra work in to try and make this idea work. The flip side is that as you get to microservices at scale, there are a whole host of problems that are very difficult for one team to manage. Some people refer to this as the microservice tax. And there's a portion of your capacity that just goes into, there's lots of new sources of problems that we've got with microservices. And that inherently is taking bandwidth around from feature delivery. I
think I would call this the you don't need Kubernetes yet problem, right? Like if you do that straight up, then suddenly that's half of your time.
Yeah, exactly. But I still think that method could work very, very well. But in that situation, you're not trying to say, look, this is going to work for everyone. You say, this works for ourselves. Do other people want to use this idea? If they do, now we should potentially look at what things that we might want to do together to more efficiently use this technology at scale.
Yeah.
And I think that model can work. I think the issue is just that often developers, don't always have the best reasons for using microservices because they often only see a small part of the picture anyway, and it's often based on fashion. And B, they're often not a great advocate for organizational change. I'm a great believer in Dan Pink's 3 pillars of motivation for employees, right? Autonomy, mastery, purpose.
Yeah.
I like that. And a lot of developers who are trying to adopt and advocate for microservices in their organization have completely and utterly been starved of mastery for a long time.
I really like this. Yeah, that's a good point.
They've not been given an opportunity to grow their skills.
Yeah.
And so they're like, this is fashionable. My boss might have heard of it. Let's do it.
And it's interesting, right? There's all these difficult challenges we're talking about are like, puzzles to solve. Let me at them.
Yeah.
I get that.
And if that's the only reason you're doing it, then, we've got an awooga going off. We've got to have conversations. This bad things are going to happen. But even if they are using it for the right reasons, they're often not able to advocate necessarily the wider organization for why this should be happening. And they say, how can I tell my boss on microservices? Like, your boss doesn't care about microservices.
Yeah.
The users of your software absolutely don't. So what you need to talk about is the problems that your organization is facing and how this approach is going to solve those problems. Then your boss will care. Anchor that change you're trying to make in terms of a benefit that you're trying to bring. And then also be really honest with yourself that there might be simpler ways to solve those problems.
Yeah, I was going to say, it usefully forces that question as well, right? Like if you ask yourself, hang on, why are we doing this? How do I sell this? And the answer is, not really. Like maybe this doesn't give us a lot of benefits. That's telling you something that maybe this isn't the right way to go.
Absolutely. This is also about context as well, right?
Yeah.
The flip problem is that organizational, we're going to microservices. And a client, this is about 3 years ago, it was a big telco. And the same day I arrived, the CEO put out a statement. Well, this organization is massive. And the CEO put out a statement internally saying, we're moving to microservices and cloud native technologies so that we can increase speed of delivery and reduce cost of delivery in the next 12 months. And the only things I could say to that statement were, firstly, you're not going to go faster and it's going to cost you a lot more money.
Yeah.
Right. Effectively, these are implementation details. Microservices are an implementation detail. So, when you get those top-down statements, it's worrying because often they're not rooted in actually any real understanding about what they can do. And I did a workshop it would have been Sydney about 5 years ago. And I had these 3 people that had come from a marine research agency. And obviously in Australia, that's like sharks and stuff. That's cool. Right? Sharks and jellyfish, cool. But what's that got to do with microservices? And they said, well, look, our boss told us to come here. And so I was like, okay, cool. So why did your boss want you here? Okay, you can ask our boss. Our boss is sitting behind us. I said, okay, boss, why did you send your 3 minions here? I didn't use the word minions. And he said, well, our CTO said we're doing microservices. So I figured we better find out what they are. And it's like, thou shalt, you will. This problem is made significantly worse by the fact that, decentralized organizations would often have enough cash and resources to then fall into the next trap, which is, okay, we're going to go to microservices, right? What are all the problems that people might face with microservices? Right, let's solve them all now.
Oh, no.
And so then that's when the consultants rain down from the sky. And lo, there are Kubernetes clusters built.
And a DevOps team managing those Kubernetes clusters.
Oh, no, platform team. Platform teams are more expensive than DevOps teams.
Yes, the platform team.
The phrase I like is, a plan never survives first contact with the enemy, right? Is an old saying. The Mike Tyson version of that is, everyone's got a plan to get punched in the face, right?
Yeah.
There is that thing that happens when those enterprise organizations think, we're going to have all these problems. Let's build a platform to solve those problems. They spend 6 months doing it. It actually takes them a year. And then the first team to try and use it just find it to be an absolute nightmare.
Yeah.
That's the other extreme.
Because again, it wasn't consumer-led, right? There was no feedback loop. There was no user interaction with what was being built, which is just classic software problems, right? It's not specific to microservices. It's a lesson that you can learn from other arenas and seems to be just as appropriate here, which is really fascinating to me. I think that the same patterns work.
Absolutely. And this way, it's also boring.
Yeah.
This is the same things we went through when we're talking about DevOps or continuous delivery or agile enablement, and I've been all through all of those. It's the thing that microservices has, even more so than those other organizational change type things I talked about, is a very vibrant technology space sector, with lots of VC money going into big tech companies who are pushing their products. So with Agile, what could you push? Consultancy, but not product, really. DevOps, they changed it into being a tool-driven thing when it was never about tools.
It's called Azure DevOps.
Well, DevOps in a box. But with microservices, there are some legitimate problems that you'll encounter at scale that technology can help with.
Yeah.
But that's different to saying that we need to solve those problems today.
Yeah, that's a really good point, Sam. I hadn't thought about that. That there's money involved at breaking it as usual.
Vast amounts.
Yeah.
Vast amounts. I think we do have to recognize that underpinning this structurally, we've got a lot of money put into tech startups, and that money has to be converted into product development and sales. You've also got a lot of existing companies that work around that infrastructural operational space that need to continue to have those revenue streams. And they are, effectively what some people call microservice washing. Now we've added microservices. And as a result, this is a bewildering world for organizations to navigate. And it can be an attractive proposition to just say, I'll buy that and it will solve my issues for me.
Yeah. Especially when you have these large scale problems that are going to require engagement and strategy and long-term work to fix. Someone coming along and saying, oh, we can fix this for you. It'll cost this much. Done. It's very, very tempting.
And if you want a little bit of the insight as to how crazy this world can be, if you're trying to think about it from a point of view of someone trying to work out what tech they should use, go to Google, type in the words CNCF space landscape, and go look at the picture on there.
I'm going to do that now because I'm curious.
Yeah, go to landscape.cncf.io.
Yeah, I've got it.
And then what you'll have to do is zoom out.
Wow.
And then zoom out again, and then zoom out again.
Yeah, we'll definitely put this link in the description because that's amazing.
Now this is not a diss on the CNCF. It's not a diss on the Kubernetes at all. This is actually a reflection of how good a job that Kubernetes, and the CNCF have done in terms of creating an ecosystem where multiple different tools can play. So what you'll see on this website is basically the different almost categories of tools or technologies or problem spaces that you might have in the area of building cloud native software. And I would say narrowly cloud native software where Kubernetes is the bit underneath everything. And so you've got a box around platform. You've got a box for continuous integration. You've got a box for service mesh. So in the service mesh box alone, there are 14 different choices for a service mesh. And there's a separate question, which is, do you even need a service mesh? So
I think it's interesting to me because I think microservices I came to as someone who heard about them and heard the hype. My initial reaction was definitely skepticism. And I think if there's lots of noise about it, it's probably worth looking at, but also slow down, think about what the benefits are, run small experiments, this kind of thing, which again is boring. is a standard technique that has kept working.
But it, argue this is a scientific method at some level.
Yeah.
I mean, this is the thing I wind it all the way back to. What are the challenges you're facing right now that you can't solve in any other way? Or what are the things that your organization is going to do in the near future that you can't work out how to do without doing microservices? But focus on that goal. I spent a lot of time working with organizations moving to the cloud. Often the reason for moving to the cloud was around gaining access to excess capacity. rather than a 6 month or more lead time to get new hardware.
Do you remember when we had to build hardware ourselves like animals? It was awful.
Rolling around with network cables in the dirt in the cave.
Yeah.
What I try to explain to people is my default position is that you shouldn't use microservices unless there is a good reason.
Do they instantly say to you, but you wrote the book, you've written a book, what do you mean don't use them?
Which my response to that is, yeah, I wrote the book, which is why you should pay attention to me.
Yeah, I've looked at it a lot, yeah. We talked a little bit about it not being good for things to be top down, and also the challenges of doing this as kind of a single person who's interested in it. How do you help everyone get involved? Like, how do we make architecture a thing that's for everyone rather than for just the technical architect hat?
I think there are some things that need to be, not top down maybe, but widely communicated. And those things that are important are company vision and culture. So I think that does need to happen. So I think that's the underpinning of where we're going and who we're doing.
Okay.
In terms of the architectural stuff, I start thinking about the architectural vision. We need a vision for our system architecture.
Like, where are we going? What should it look like eventually?
Yeah, and what do we need today?
Sure.
And for me, that comes back to understanding where the company's going. So if you've got no sense of the company direction or the culture of the company, i.e. how we're going to go about getting in that direction, those two things are inputs to your architectural vision. So then your architectural vision is based on and rooted against how we deliver on where the organization wants to go and what the organization needs us to do. So those things have to be connected. This, again, is why the ivory tower is a problem, right?
Yeah.
Gregor Hope has this analogy of the architect's elevator. I mean, he thinks about it like a skyscraper. You're going up to the big wigs in the top office to talk about where we're going as a company. And then you go back down to talk to the developers about, okay, well, I think we might need a system architecture to help us do these things. What should we do? A lot of this is stylistic. I'm quite, I think, collaborative as an architect, but I think, you need to have a clear architectural vision. The process of how you can come up with that architectural vision, it should be collaborative, but someone needs to be responsible for making sure we have one.
Yeah.
And it might be one or two people or two or three people or whatever, but multiple people might have an input into that. And so if we think about the classical, you've got these sort of independent teams owning their stuff, blah, blah, blah. Architecture often will need to span across those teams. And so in those types of organization, I see the role of that architectural vision as being people who've got bandwidth, mental bandwidth to actually spend time with the teams and also look across the whole piece.
Yeah.
So that for me is almost like the architectural function as an enabling team, right?
Like, yeah, if you want to do this, this is how your teams are going to have to implement it and the consequences that's going to have.
Yeah.
That kind of thing.
But also more, if you tell me we've got to do things like this, it's going to make my life miserable.
Yeah.
So let's have a conversation about that. There's a term I first heard from Frank Bushman. He talked about this idea of developer habitability. He's not the originator of the term, but I've heard it from him first. And it's an idea that as somebody who might make a decision or a recommendation around, say, an architectural approach, the decisions that you make have a significant impact onto the daily lives of the people implementing that architecture.
Yeah.
And so you have a responsibility to understand the impact that those decisions have, and you need to engage with people about that. And I'm being really clear here, like, it's not the job of an architect to come up with the vision. The job of the architect is to make sure there is an architectural vision.
Yeah.
And a lot of the time that may well be, that could be simple things. Let's just get like 10 of us together, tech leads from each of the teams, and we're going to have a big chat about it, come up with an idea. Okay, well, I'm going to polish this. I'm going to explain this to the rest of the company, and we'll work together to refine it. And that could be quite a collaborative process.
Yeah. And probably is better if it is. Like, if you're managing to get more people's input, generally that leads to a better result.
Absolutely. I think the challenge is often when this stuff falls in the cracks, where people just assume this stuff's going to happen naturally. And it might, when you've got 20 or 30 people, it won't at 100. Yes, that's the unhappy balance I think some people find. It's like, it's not top down, but there are still responsibilities for anybody who has to ensure that technical vision is being carried out.
So we've got a few questions that we ask everyone. I'm interested in, who in this industry are you inspired by?
I'm going to differentiate between being inspired by and aspire to be like, because I think they're two different things.
Okay, yeah.
Because there are people that inspire me a lot, and there are people that seem to have boundless energy to help build community and kind of really sort of magnify their impact and bring other people with them. And I'm thinking of people like Kelsey Hightower in the Kubernetes community.
Yeah. People
like Bridget Cromley in the sort of DevOps space who did so much work kind of helping get DevOps conferences and all those other things going. And then people like Angie Jones, right? Like in the Java and the testing world, just seem to have endless enthusiasm to kind of bring people with them. They don't seem to be overly snarky or cynical either, which is a trait I've never had. And they just, they get things going. And it's like, I'm amazed at the work they do. I think it's fantastically, it's greatly inspirational. I couldn't do what they do, right? Because I'm not that person, but I really admire the work, and I'm glad we've got people like that in our industry, and we'd be much poorer for it if we didn't. I think there's other people that sort of have set out a path that I think is more like what I can do. And probably the person that comes to mind there is Martin Fowler, because I was fortunate enough to work with him when I worked at ThoughtWorks. But, a lot of what he seems to care about, we work in quite different ways. But this idea of collecting information, trying to explain that information in a good way, and then sharing that information with a much wider ecosystem. So again, I'm trying to have a wider impact than that, but by maybe through writing or presentations or workshops. So Martin is from someone that I've learned a lot from, just observing what he does, and he's given me advice in the past around that. So that's, again, they inspire me, but Martin's a more aspirational type of person I could be more like than the other three, because the other three don't seem to have a built-in cynical view of the world and seem to have a lot more energy than I do.
It takes all kinds, though.
Oh, yeah, absolutely.
It takes some of us to go, slow down, don't use microservices.
Yeah.
It's good.
Yeah.
That's really nice. I think that habit of what have I learned and then sharing it back is really good. So cool. What's the best thing that's happened to you this month?
What is the best thing that's happened this month? The book got released. I suppose it started getting to people's hands. The best thing this month was definitely me finally getting my hands on the second edition of Building Microservices.
Oh, cool.
I had some copies sent to me from the US that took a while to arrive. So yeah, that was really nice. It's just holding it in my hands was very good.
Yeah, something special about that.
It is, and also realizing just how badly I'd failed at my goal of writing a smaller book.
Has it got bigger in the second edition?
Oh, it's more, yeah, oh yeah. Oh yeah. It's significant. People seem to really like it, which is great. I'm getting nice feedback. I had a lot of feedback along the way. And the only reason the book's as good as it is largely because of the feedback I had from lots of people that gave their time and helped with that book. So Martin Fowler, Sarah Wells, and Daniel Bryant put a lot of feedback into that book as well. They're my reviewers. But actually seeing it and seeing people now talking about it and seem to like it, that's a big kick. So that's been the best thing that's happened to me this month by far.
Oh, that's great. I think that nicely covers our do you have anything you want to plug question, probably. Although actually, I think you have courses as well. Do you want to talk about those?
Yeah, well, I guess, I work as an independent consultant. I sort of mix my time between writing the book. So there's information about building microservices over at my website. I also run private classes for companies if they want to learn about microservices and do private consultancy. So I'm working with a number of companies, helping them, guiding them really through sort of a microservice journey, really.
So people can reach out to you if they need help with this sort of thing in more detail. You can come along and help those organizations.
Absolutely. I also run a lot of public events over at the learning platform at O'Reilly. So if you go to learning.o'reilly.com, you can sign up for a free trial there. You can read my books. I do regular sort of webinar style training there, as well as running events on the infrastructure and operations side of things. So we do like every 2 months, we have like a half-day conference. And then every month I do like almost like a podcast, Ask the Experts thing.
Oh, cool.
So some really interesting people there. So if you subscribe to that platform, you get access to all of that. And if you're an ACM member, you also get access to those platforms for free as well. Okay,
great. We'll link those in the description with any luck. And finally, can you tell me one truth and one lie about yourself?
Oh, okay, yeah. I'm a really good rock climber, and I used to babysit for a punk rock guitarist. Well, the kids of the punk. He was old at this time, but it was the kids.
Okay. Well, we're almost at time, Sam. So I'm going to say thank you very much for coming along. Thank you for talking to me. It's really interesting. I think, as usual, I've learned a bunch from you, and I think I could talk for hours more. But yeah, thanks a lot.
Thanks so much for having me, Kel.
And that wraps up my chat with Sam Newman. I actually took quite a few things away from this, but I'll try and stick to just a couple. The first is there's real pressures driving you towards microservices when they might not be the right choice. I don't think I'm the only one skeptical of hype cycles in technology, but it was really interesting to dive into the causes of that hype, the money, etc. And the second is maybe a more practical point. The lessons we've learned around technology are still relevant to microservices. Start small, experiment, change course if you need to, think about the goal of what you're doing. Those are all things that are applicable to technology in general. I've sometimes not focused enough on those things in the past, to my peril. Every other episode, it's story time. Stories are for everyone. They're a great way to share our experiences, inspire people, or make us laugh. This week we've got Claire, who's telling us a story about a neighbour.
This is another story about assumptions. It's probably a familiar story. The neighbour who uses power tools at all hours. The banging, the drilling, the scraping. There can be something uniquely stressful about a loud thudding or a whiny drill that seems to seep through the very fabric of the house. And how come it feels like it's right at my elbow when I know that there are at least 2 walls between me and it? And then there are the hammer thuds that are intermittent. So just when you think they're done, another one comes. And when you're confronted with this disembodied, faceless nuisance, it can be easy to demonise the source. They're so inconsiderate. They don't even care about me. Don't they know what it's like? And once you've been through those thought processes, you can get to the point where you don't even think about starting a dialogue with them about it. Maybe there have been some minor confrontations in the past, and as a result, you've convinced yourself there's not even any point in appealing to reason. So in my case, my neighbour had been doing some refurbishments on and off for 25 years, and we didn't have a brilliant relationship. So when he started on another prolonged project and I had a podcast episode to record, I was thinking, it's no use. I'll just have to decamp to the office and record the episode there. I just don't know when drills and banging might start up next door. But then I had to record a rearranged interview at short notice, and it wasn't possible for me to go elsewhere. So I just had to cross my fingers and hope for no noise. And then 10 minutes before the interview was due to start, the drilling started. And it turns out my neighbour was actually right outside my window. And so, I had no choice. I was going to have to throw myself at his mercy. And actually, we'd had a few friendly conversations in recent weeks. He'd been keen to tell me what his latest plans were. So I went outside and I just kind of hovered at his elbow because it was too loud for me to make myself heard, until finally he noticed that I was standing there. And he looked at me and I thought, oh, God. But I said, look, I'm really sorry, but is there any chance you could just take a break for an hour? It's just that I have to record an interview and I won't be able to get a decent recording with this much noise in the background. He looked at me. There was a big pause and then a giant smile. Of course, he said. He was planning to stop for something to eat anyway. He went back into the house. I went back into the house. Just as I was about to start recording, there was more drilling. And I didn't know what to do at this point. But it only lasted for 30 seconds. And then there was blessed silence. And I recorded the interview with no hitch at all. So what's the lesson? Well, it made me realise just how easy it is to demonise people. The less you communicate with them, the easier it is to imagine in your head that there's some kind of evil presence. And it's actually easier to cast them as a demon in your head than it is to go and just do the communication, because then you don't have to make that effort. But that negative image in your head and the idea that there's somehow an enemy creates a whole lot more stress and misery. And you can convince yourself you know them because they're making an unpleasant noise, for instance, and that's causing you discomfort. Therefore, you assume some kind of malicious intent. But of course, there's no reason to think that. And all I had to do was be friendly, apply a little bit of charm, explain my situation, ask for sympathy and a bit of a favour, and that way he got to be the good guy, and we were both happy.
For this final segment, Making Life Better, myself and my colleagues make some suggestions for small things we can do to help out, which could be helping the person next to us or a little further afield.
Today's advice comes from Owen Piggott, one of our senior engineers, who has some advice on making the effort to help people who are struggling, staying calm and showing empathy. Owen, do you want to tell us a little bit more about that?
Yeah, sure. So when we're all working together and trying to deliver something, it's easy for one person to get lost from a group and be struggling silently to deliver a task they may be working on solo or as a pair. And it's really good to identify that, because essentially we're working on one complete picture for the customer. And if one person's struggling, the whole thing can suffer. But it can start to spread as well. If one person's stressed, another person can get stressed. So I think the best way to deal with that is to stay calm yourself and show empathy to those around you.
So do you have any advice for sort of bridging that gap? Like if you do notice someone who maybe isn't themselves that day, do you have any advice on sort of like taking that first step?
Yeah, I'd generally stick to statements that are questions and try to get as quickly as you can what the problem is out of them. Don't tell them what you think the problem is, so that people can give you the information in their thoughts.
No, I'm completely with you there. Most of the time it's sort of having that moment of realizing there is someone who is there to listen, not to provide a solution, but someone who is there to hear it all out and who cares.
Yeah, exactly. And to help put problems into perspective as well. It's easy to have a small task that's going wrong and we think it might be the end of the world or the end of the project. And when you speak to somebody else, it's suddenly put into perspective that we can solve this together. It can be fixed quickly. And there are always problems, but there are always solutions.
Couldn't agree more. Well, thank you very much, Owen.
Thank you.
Well, that's almost it for this episode, but I have a little treat for you. We have 3 copies of Sam's book to give away, kindly provided by O'Reilly, his publisher. These are DRM-free ebook copies, and if you'd like to win one, send us your entry to makingtechbetter@madetech.com. You don't need to include anything in the email body, but please make the subject line Building Microservices Giveaway. If you'd prefer to read these details, that's all in the episode description. We'll then pick 3 out of a hat and send you some free stuff. You can find my guest Sam Newman, me, Kyle, and our sponsor MadeTech all on Twitter. Sam's at Sam Newman, I'm at KJD Chapman, and MadeTech are at MadeTech, which are all in the episode notes as well. If you've enjoyed this, we'd love a rating or review on whatever podcast platform you're using. It really helps us to hear how we're doing, and it will help more people find it as well. Thank you to Rose, our editor, Gina Cady, our virtual assistant, Viv Andrews, our transcriber, Richard Murray for the music, there's a link in the description for that, and to my colleagues at MadeTech for helping out. Claire Sudbury, Jack Harrison, Carson Robb, and Lara Plaga. We publish new episodes every fortnight on a Tuesday morning. We'll see you next time. Thanks for listening.